Hello, everybody, and welcome to another edition of Science on the Sphere at Home from the James E. Richmond Science Center. I am Patrick Rowley from the Science Center, taking you inside my home to look at SOSx, or Science on the Sphere Explorer from NOAA. It's an app you can get on your phone or tablet. I have it pulled up on the TV right here now for us to take a look at a few things here. The first week, we just kind of looked at some new fun stuff on the app. Last week, we looked at some information about satellites. This week, the theme is going to be air and different things we can see in the air. So we're going to start with this one here. This is a look at atmospheric chemistry. So I'm going to pull that up on the screen bigger for you. All right, so there we go. So like I said, this is atmospheric chemistry. It's a model, the GEOS-5 model, and it's a simulation of kind of a visualization that shows how winds basically lift the aerosols from the Earth's surface and from the ocean surface and transport them up in the atmosphere and around the globe over just a one-year period here on this imagery. And so what this does is it allows scientists to identify kind of sources of these different sorts of aerosols in the air and pathways that they take, which can influence weather and climate. Now, we can see some different colors, and we have this little legend here that we can see right there, showing us how we have the kind of reds indicating some dusty areas. We can see some of that coming off the Sahara Desert there in Africa, some of them moving into the Atlantic Ocean there. And so that's one color indicating those sorts of dusty materials. Sometimes you can see this get interaction with some tropical cyclones and things like that, not this time of year that we're looking at on here. If I were to, let's see, when does this start? Yeah, let's start it there back in August. And you can kind of see how that pattern is a little different in the summer months. We also have some of the blue indicating, you see that over a lot of the ocean areas, because that indicates sea salt up in the atmosphere moving around that's lifted up off of the ocean, present most in the mid-latitude areas. You can see that over many of the oceans there, that sea salt being transported globally. And then in green, we have some black or organic carbon. And this is primarily looking at like kind of burst of this carbon from burning. You can see a lot of that down in South America and Africa from the burning of forests and rainforests there. And then lastly, we have sulfates in white, which we get a lot of that from just the burning of fossil fuels over the US, Europe, and in Asia as well, a lot there in Asia. So this is the burning of fossil fuels. You'll also notice, though, if we look in Africa, we have a little bit right there, and that's from this persistent eruption from a volcano in Mozambique. All right, and so there it goes. Finally picked up on the screen. We can see how that is showing us some sulfates in the atmosphere there as well. All right, so that's one look at a certain part of the atmosphere. Now we're going to look at another data set. Still, let's see, go to air. And this time we'll be looking at clouds with precipitation, bomb cyclone from March of 2019. So this data set combines what you normally think of as your cloud satellite data, as well as satellite radar sort of precipitation data. And so what the precipitation does is it changes the naturally occurring microwaves that are emitted from Earth's surface and atmosphere. And then so what we can do is the satellites have instruments that are able to detect or pick up on those changes. So this is from last March, just over a year ago, when we had a huge kind of known as a bomb cyclone over the central part of the US. So if I back it up to the beginning of the animation there, you can see a lot of that precipitation that fell in the form of big rains and big snows, blizzard across the central part of the US, and then moved to the East Coast with lessening amounts of precipitation. But right there in the middle part of the country is where we had that bomb kind of cyclone. or bombogenesis, from when we have a big low pressure system. Now, we're going to finish up with one that just looks really kind of cool. It is a winds data set, wind streamers from the FIM forecast model. Okay, so you'll see these little streamers indicating wind direction and wind speed. So this is an example from last year as well of this model, okay? And it is the FIM forecast model, which is the flow following finite volume isosahedral model, all right? Say that like one time fast. So rather than using kind of square grids that most forecast models use, this uses those isosahedral shapes like hexagons and pentagons with this. Think of it as the Earth as a soccer ball, and you have those kind of grid shapes versus or those pentagon or hexagon shapes rather than squares, right? Making up this model. Okay, and so what we have are the colors you can see on here, which is basically the wind speed. Okay, it's not temperature on this one. So we have the blues indicating some slow wind speeds up to the reds indicating much faster wind speeds. Some areas you can see here, like in the Atlantic, where we have some areas that are very much kind of twirling together here, right? And so what that does, or swirling, right? So, and they're kind of close together. So we have low pressure and high pressure systems that we're able to see through these winds. Now, this is depicting winds at the 250 millibar levels, pretty high up in the atmosphere, around 35,000 feet up in the atmosphere. So that's all I have for you today. Have a good weekend, stay safe, wear a mask, stay at home as much as you possibly can, and enjoy science while you have this time at home to take a look at it. So have a good one. Bye.